Number 1. Molarity. So what is molarity? Well, it's the concentration of the solution that tells you the ratio of solute, the substance being dissolved, to the solvent, the liquid substance it's being dissolved in. First problem. An aqueous solution is prepared by diluting 3.30 milliliters of acetone with a density of 0.789 grams per milliliter, with water to a final volume of 75 milliliters. The density of the solution is 0.993 grams per milliliter. So what is the molarity? Before we use molarity formula, which is M equals N over V, we'll need our units correct. So first off is the mass of solution, which needs to be in grams. You get 75 milliliters multiplied by its density of 0.993 grams per milliliter. To cancel milliliters, you get 74.475 grams. And for the mass of acetone is 3.30 milliliters multiplied by 0.789 grams per milliliter, and you get 2,637 grams. To get molarity, we need our acetone to be in the unit mol. So our moles of acetone is 2,637 divided by 58.0794 grams, which is the molecular weight of acetone, and you get 0.04483. So our molarity would be 0.04483 moles divided by 0.0750 liters, which is a total mass of solution rounded to 75 divided by 1000 to get unit liters. So our final answer would be 0.598 m. Number 2. Boiling point. This is the temperature at which the pressure exerted by the surroundings upon a liquid is equaled by the pressure exerted by the vapor of the liquid. Second problem is, what is the boiling point elevation when 147 grams of lactic acid, C6H10O5, is dissolved in 647 grams of cyclohexane, C6H12? The boiling point constant of cyclohexane is 2.79 Celsius per m. First, we must determine the molality of lactic acid solution, which is 147 grams divided by 162.14 grams per mole, divided by 0.647 kilograms, and we get 1.40,127 m. Then we utilize the freezing point depression formula, and we get X equals 1 multiplied by 2.79 Celsius per kilogram mol with negative 1 multiplied by 1.40,127 moles per kilogram, and our answer would be 3.91 Celsius. Number 3. Calorimetry. This is used to measure amounts of heat transferred to or from a substance. Problem 3. How many milliliters of water at 23 Celsius with a density of 1.00 gram per mole must be mixed with 180 milliliters, about 6 ounces, of coffee at 95 Celsius, so that the resulting combination will have a temperature of 60 Celsius? Assume that the coffee and water have the same density and the same specific heat of 4.184 joules per gram per Celsius. It wants to know how many milliliters of water at 23 degrees of Celsius with a density of 1 gram per milliliter must be mixed with 180 milliliters of coffee at 95 degrees Celsius, so that the resulting combination has a temperature of 60 degrees Celsius, and we can assume that the coffee and water have the same density in the same specific heat. So essentially we can say that the Q of water is equal to the opposite of the Q of coffee. So MC delta T for the water is going to be equal to negative MC delta T for the coffee. We don't know the mass of water. That's what we're trying to solve, for we know the specific heat of water is 4.184 joules per gram degrees Celsius. And we know that the change in temperature of the water that we desire is that it ends at 60 and starts at 23. And that has to be equal to the negative of 180 grams of coffee. Because if I have 180 milliliters and I assume that the density is 1, I also have 180 grams times the specific heat of water, which they said was the same as the specific heat for the coffee times the change in temperature. Here it wants to end at 60, but it's going to start at 95. So my delta T is going to be negative in this case. So here I'm going to wind with 154.808 times the mass of water, which is what I'm trying to solve for, is the negative of negative 26,359.2, and my units that I'm going to be left with are joules, because degrees Celsius will cancel out and grams will cancel out. Here I'm still going to have joules per gram. So I'm going to divide both sides by 150.4.808. My units that I'll be left with will be grams, and the overall mass of water that I need to add is 170 grams of water.